A few weeks ago, the James Webb Space Telescope detected a faint, unfamiliar signal, a spectrum unlike anything it had seen before. The source? A traveler from another star system, 3I Atlas. As it swung past the Sun, Webb's sensors recorded an impossible transformation, a burst of blue light, growing stronger as the comet drew closer. Let's be clear about what just happened. On October 29th, Atlas was only about 220 million kilometers from the Sun, roughly the same distance as Earth, just slightly farther. At that range, solar radiation hammers the surface. Most comets start venting massive amounts of gas and dust. Some fragment entirely. Atlas, still intact. But here's where things get complicated. 3I Atlas survived, yes. But the way it brightened and the color it's showing don't fit any comet model we have. Just before perihelion, Atlas became more luminous than ever before. So bright that if someone were watching from Mars, the view would have been breathtaking. One thing is clear. The closer Atlas moved toward the Sun, the more its emissions surged. Before we go deeper into what the James Webb just uncovered, take a second to like this video and subscribe if you haven't already. Because the next few weeks could reveal something no telescope has ever seen. What puzzled scientists even more was the mysterious color shift that made the comet appear bluer than the Sun itself. This isn't supposed to happen. Dust makes things look redder, not bluer. Atlas's surface should be about 20 times colder than the Sun's 5,800 Kelvin surface. Cold surfaces glow red. Always. The blue glow suggests the presence of volatile molecules like cyanide or ammonia releasing bright visible light. These gases outshine the red light reflected by dust, giving the comet its strange, intense hue. Interestingly, this is already the third color change recorded for Atlas. Earlier, it glowed with a greenish tone for several weeks, and the cause of that color is still unknown. This pattern shows Atlas is highly active, releasing materials at a rate many times greater than most comets in our solar system. These signs support the theory that Atlas may be an ancient traveler formed on the distant edge of a long-lost star system, wandering through darkness for billions of years before finally encountering sunlight. A striking image from the Very Large Telescope added even more intrigue. It captured the comet's gas and dust cloud shifting shape constantly, forming a hazy stream that seemed to stretch directly toward the Sun, as if the star itself were pulling and molding the comet's outer layer. Scientists now wonder whether this is normal physics or evidence of some unknown interaction between the comet and the Sun's magnetic field. The newest data from James Webb revealed another perspective on this mysterious object. When viewed in infrared, the findings confirm that Atlas's surface has endured extreme radiation during its long journey through interstellar space lasting billions of years. Over that time, powerful cosmic rays from across the galaxy bombarded its surface grain by grain, molecule by molecule, gradually changing its composition through countless chemical reactions. This constant exposure created a dense, ancient crust estimated to be 15 to 20 meters thick, about 50 to 65 feet. Scientists consider this layer a kind of geological record of the universe, preserving traces of every impact and ray of energy. It may include chemical clues from solar system's earliest days. If humans ever land on this comet, especially while it's far from the Sun, they wouldn't be standing on a dead block of ice, but on a living witness to the universe's early history. The crust of Atlas has been shaped for billions of years by the storms of space. Researchers believe it may hold the key to understanding how the raw materials of the cosmos evolved and even raise a larger question. Could organic compounds, once transformed by cosmic rays, play a role in creating life elsewhere in the universe? This comet is far more than a frozen object drifting through space. It's a memory of the universe itself, carrying the story of billions of years that sunlight is only now beginning to uncover. That ancient exposure also helped solve one of the comet's earliest mysteries, its unusually high amount of carbon dioxide. Early measurements showed carbon dioxide levels far beyond anything expected, and scientists were initially unable to explain them. But new infrared data now suggests the answer lies in the same long period of cosmic radiation. As the comet wandered through the galaxy, constant exposure to energetic particles gradually turned surface carbon monoxide into carbon dioxide. Over billions of years, this slow process enriched the outer crust with carbon dioxide, creating the distinct chemical signature now detected by James Webb. For astronomers, this changes how we understand cometary chemistry. It suggests that the gases and ices released from comets are not untouched remnants of the early universe as once thought, but materials that have been chemically transformed through eons of radiation. In other words, what we see today is not pristine matter, but reworked material shaped by cosmic time. This leads to another question. Could layers of untouched ancient ice still lie beneath the hardened crust, holding the true record of the comet's birth? If the heat at perihelion melts part of the outer shell, it might expose those hidden layers for the first time, allowing scientists to study chemical evidence from the comet's original home in some distant star system. Another discovery made Atlas even more fascinating. It contains slightly more nickel than other known comets. While not yet confirmed, this finding hints that different star systems may form with varying amounts of heavy elements. That idea opens a new path for studying how planetary materials differ across galaxies. In this sense, Atlas is not just a comet heading toward the Sun, it's a time capsule preserving the complex chemical history of the universe. A recent study offered an intriguing new perspective on why interstellar comets like Atlas are so significant. These wandering icy bodies could be the missing link in the mystery of how planets form. Traditionally, scientists believed planets are born from countless collisions among dust grains and rocky fragments orbiting young stars. Yet this classical model faces a major problem known as the meter barrier. Once particles grow to about a meter in size, they tend to bounce off one another or break apart instead of sticking together. The new theory proposes that interstellar comets might have provided the breakthrough. These ancient objects, expelled from their original planetary systems billions of years ago, travel endlessly through interstellar space until they encounter new star systems. When such a comet passes near a young star, surrounded by a swirling protoplanetary disk, the star's gravity can capture it. Once trapped, the comet could serve as a seed core, a stable solid body that attracts surrounding dust and pebbles. This process would bypass the meter barrier and enable rapid growth of planetary embryos. If this model is correct, it suggests planet formation depends on interstellar exchange, where comets from one star system help seed planets in another. Today, as Atlas continues its journey through our solar system, scientists are racing to learn as much as possible before it disappears again into interstellar space. Following perihelion, Atlas was imaged by the Lowell Observatory's Discovery Telescope, marking the beginning of a new chapter in its study. As it draws closer to Earth in the coming weeks, its brightness is expected to increase, providing clearer views and richer data. The most anticipated moment will come on December 19th, when Atlas makes its closest approach to Earth. At that time, observatories worldwide will capture high-resolution images and spectra, analyzing the composition of its nucleus, gas emissions, and fine dust released as sunlight heats its icy surface. The upcoming Clipper mission is even expected to pass through Atlas's plasma tail, collecting particles of dust and charged ions to send back for laboratory analysis. This could yield invaluable clues about how comets interact with the solar wind and how they might have contributed to delivering water and organic molecules to young planets. By March 2026, Atlas will swing past Jupiter before vanishing into the outer darkness, traveling so fast that it will soon leave the solar system forever. Once it departs, the chance to study it will be gone perhaps for millions of years, if it ever returns at all. Based on all the data gathered so far, scientists can confirm that Atlas is one of the strangest and most unpredictable celestial objects ever observed. From the moment it entered the inner solar system, it began to challenge almost everything we thought we knew about comets. Its three dramatic color transformations and the extraordinary surge in brightness as it neared the sun have left researchers puzzled and fascinated. No existing comet model has ever predicted such erratic behavior. These changes are so extreme that they hint at complex physical and chemical processes happening deep inside Atlas processes humanity has never directly recorded before. What makes this even more astonishing is the discovery of a thick outer shell several meters deep that has been heavily irradiated by cosmic rays. This finding has forced scientists to completely reconsider how comets are formed, how they evolve, and even how we should study them. The outer crust of Atlas is not untouched material from the birth of the universe. Instead, it has been reshaped and chemically altered over billions of years through constant exposure to high-energy radiation in interstellar space. This radiation has turned Atlas into a kind of living archive, a natural laboratory traveling through the cosmos, where every dust grain carries a record of how matter in space has changed and evolved since the dawn of time. Could Atlas be more than just a comet? Could it be an ancient messenger flung out from a distant and long-dead star system, carrying within it the chemical fingerprints of worlds that no longer exist? Or might its thick, irradiated crust conceal complex organic compounds, the essential ingredients of life that have yet to be discovered elsewhere in our solar system? Some scientists even speculate that the intense cosmic radiation Atlas has endured for billions of years could have triggered unknown chemical reactions, creating entirely new organic molecules. If that's true, Atlas might not just be a comet. It could be a drifting archive of potential genetic material, a cosmic time capsule carrying the precursors of DNA through the galaxy. If any of these daring hypotheses prove correct, Atlas could help humanity confirm for the first time that organic matter can move freely between star systems. This would lend powerful support to the panspermia theory, the idea that the seeds of life can travel through space, carried by comets, asteroids, and interstellar dust, and eventually take root on planets like Earth. Time is short. Scientists only have a few precious months left before Atlas fades into the cold darkness beyond Jupiter's orbit, possibly never to be seen again. So, here's what I want to know from you. What do you think we'll discover about this interstellar traveler in the coming weeks? Will it survive its journey intact, or are we about to witness a dramatic fragmentation event? Leave your thoughts in the comments. I read every single one and genuinely want to know what you think. And if you want to follow this story as it continues to unfold, hit subscribe and turn on notifications. I'll be releasing follow-up videos as new data comes in, especially after the December 19th closest approach, when we finally see what becomes of 3I Atlas. Because this isn't just another comet. It's a 7-billion-year-old witness to the universe's ancient history. And whatever we learn from it could reshape our understanding of how planets and possibly life itself began. See you in the next one.